Good morning, students. I am Santhan, working as a physics faculty in Target English Medium School, Tadipatri. Today, in this part 2 video, I would like to teach what are the applications of scattering of light from the chapter of Human Eye and Colourful World in 10th standard level in our state syllabus. Okay, so in our previous video in the same chapter, I will be explaining clearly about what is the scattering of light, how it will be occurs or how it will be happen. That is, I will be explaining. Now, with help of some examples, I try to I will be explain some of the applications about the scattering of light for understanding of you clearly which one scattering of light, because I said very clearly it is a complex phenomenon. And also we discussed one small lab activity also. When in the lab activity we clearly discussed that sodium thiosulfate and sulfuric acid, when they are added in a glass beaker, initially mainly in that reaction sulfur is formed as a precipitate. During the beginning of the process, sulfur particles are very small. At that time, the sulfur particles are appears blue in color. But if you can do that experiment, it must be done under the sufficient sunlight or abundant sunlight only, by keeping in the open place. If the process will be continuously happening, the precipitate of the sulfur particles will be increases gradually. When they increase their size, the blue color of appears to become a white color. So that's why. So in the beginning of the process to ending of the process, which is formed only sulfur particles sulfur is formed as a precipitate. But the sulfur, why initially the sulfur particles appears to blue color, but further it is appears to white color by changing the size, means I said very clearly. So scattering of light is mainly depend upon the size of the particle or molecule. Applications of scattering of light. The first one is why sky appears blue in color. Listen very carefully. The first one is why sky appears which color? Blue in color. So we know that our Earth atmosphere is mainly contained two gaseous particles. One is this is the air particle. In that one mainly contains which one? Nitrogen and oxygen. These two are 98%, that is we know very clearly. So our air particles is mainly contain the nitrogen and oxygen molecules. So the average size of these two molecules is comparatively equal to the blue color of wavelength. Size equal to which color? Blue color. Blue color. Wavelength. Listen very carefully. So our Earth atmosphere is contained the air. The air is mainly contained the nitrogen and oxygen molecules. The average size of these two molecules is comparatively equal to the wavelength of the blue color light. Wavelength of the blue color light. So what is the wavelength of the blue color light? The wavelength of the blue color light is 4700 angstrom. 1 angstrom is equals to how many centimeters? 10 power minus 8 centimeters. So I say 1 angstrom is equals to 10 power minus 10 meter, that is equals to 10 power minus 8 centimeter. Now just for understanding of you only, I said that it is the imaginary only, into 1 angstrom, that is equals to 10 power minus 8 centimeter. Because of the size of the particles in nanometers, but in centimeters I will explain for you only. So 47 into 10 power minus 6 centimeter. Then it is, you can write that 47 into 10 power minus 4 centimeter. That is equals to 0. So many 1, 2, 3, 4, 47 centimeter. So that's why, so means the wavelength of the blue color of the light, we are converted into the centimeter. What is this value? 0.4047 centimeter. Means very less. Not this one, it is just approximate. Okay, not approximately. Okay, for understanding of you. What is the size of these colors? What I said that in the concept of scattering of light. Okay, so means when the light will be fall onto the any molecule or particle, the first of all, the molecule is first absorb the light and fall on it. After that, it is start the vibration and it is re-emit the light with a different intensity in all directions. That is, we know that. So, but here at the same way, okay. So the scattering of light is depend upon which one size of the particle. The size of the particle is nearly equal to the which color of the wavelength. The particle is mainly acts as a scattering center of that particle mainly. But remaining colors is also scattered, but they are with lesser intensity. Only that color is with a higher intensity. Now, why I am saying that one means that concept is involved here. So now what I said that the average size of the nitrogen and oxygen molecules is also 0.000 just 4-5 centimeter like this one, just for understanding of you only. Okay. So you are observing that 0.00047, 0.40 okay 45 centimeter. If you are observing these two values, both are nearly equal or not? Okay, very equal, means very nearly equal. So that's why what will be happening, the size of the combination, the size of the average nitrogen oxygen molecules is comparatively equal to which one? Wavelength of the which color of the light? Blue color of the light. That's why our Earth atmosphere, the nitrogen and oxygen molecules are mainly acts as a scattering center for which color? Blue color wavelength of the light only. That's why when the light is coming from the sun, it is passing through the atmosphere. So the nitrogen oxygen molecules will be scattered which light? Mostly so blue color. But what about the remaining colors? Remaining colors is also scattered with lesser intensity, but the blue color will be scattered with more intensity because this molecules is acts as a scattering center for blue color of the wavelength. The reason is the wavelength of the blue color of the light is equals to the size of the molecules present in the atmosphere. But at the same way, I say that the scattering intensity is maximum at 90 degrees and remaining when it will be less. That's why when you can see exactly like this one, okay, the sky, it is appears to which color? Blue color. But by changing the angle slightly, what will be happen? So the intensity of that one will be decreased. That's why it is appears to white or another colors. Means that mainly appears to slightly disappear the blue color or blue to white, that is appears to that. So that's why mainly, so listen very carefully. This is no need that one. What type of information or which information you can write for this one means what is the question? Why sky is appears blue in color? Explain with the help of the scattering of light. So Earth atmosphere is mainly contain nitrogen and oxygen molecules. The average size of these two molecules is comparatively equal to the wavelength of the blue color of light. So that these two molecules acts as a scattering center for the blue light only. That's why when the sunlight is passing through the Earth atmosphere, these molecules are scattered the blue light with higher intensity than the other light. Due to that reason, the sky appears which color? Blue color. Next, why the sky appears white at afternoon or noon time? Listen very carefully. One more application. Why sometimes why the sky appears white in color at noon time? Noon is nothing but afternoon. So at the noon time, where the sun is present exactly over our head, at that time we can see the sky. The sky appears which color? White in color, not in blue in color. What is the reason? But if the sun is not exactly over our head at another position, what will be happen? So means mainly except sunrise, sunset and at noon time, remaining cases the sky appears blue in color. At the noon time, sun appears white in color. During the sunrise and sunset, sky appears near the sun, near the sunset area and near the sunrise area. It appears reddish in color. That is one by one explained. First blue concept is completed. Now we discuss about the white color. Why the sky appears white color at noon time? Simply, like this one you can say that. So means according to the Kepler scientists, according to the Kepler's laws, we know that the Earth and the remaining planets revolving around the sun in an elliptical orbits like this one, not in circular orbits. So that's why here we are observing that, just for understanding of you only I say that, but it is correct according to Kepler's law. If the Earth is here, just we can say that. Because of what is our question? Why sky appears white in color at noon time? At noon time, sun is way over our head. That's why you are the one of the person on Earth here. The sun is way exactly over our head. So that's why you are observing that. At the noon time, the distance from surface of the Earth to sun is lesser than the at the another place like this place. When compared to here and here, the Earth position is longer distance from the which one? Sun. It is nearly exactly 150 crore kilometers. We know that the distance from surface of the Earth to sun is 150 crore kilometers. But when the Earth is at this position, what will happen? The distance from sun to Earth is less. Is nothing but near the poles area concept. But leave it that concept. So we know that Earth is revolving around the sun in a particular in an elliptical orbit. At that time, sometimes Earth appears far away from the sun. Sometimes it appears near to the sun. So now this concept we are considered here because of the sun is exactly way over our head. That's why at the noon time, the distance from surface of the Earth to sun is lesser than the initial one. That's why the rays are coming from the sun. At the same way, at the noon time, what will be happen? So evaporation occurs more. Listen very carefully. At the noon time, temperature is more in the atmosphere. Two reasons I will say that. At the noon time, temperature is more in the atmosphere. That's why water is evaporated more fastly. So that's why due to the higher evaporation, the size of the water molecules are increases in the air. We know that air is not only mixing the gases, it is contained the water vapor also. That's why the size of the water molecules present in the air is increases. That's why this size is comparatively equal to the average wavelength of the, what is that one? All colors of the light. Okay, the average wavelength of the all colors of the light, which one? Yellow color, but not exhibit that one. Just what I say, that means the size of the molecules present in the air at the noon time. What will happen? The size of the molecule is not exactly equal to the any color of the wavelength of the light. It is averagely equal to the all. That's why what will happen? It is scattered the all colors of light with slightly difference in the intensity. That's why before vanish, all colors are reaches to our retina. Then all 7 colors are reaches, which is color is appears white color only. So here I will be say the 2 reasons. Listen very carefully. First one is, okay, what is that one? Simple one. At the noon time, temperature is more in the atmosphere. That's why evaporation is occurs highly. Due to the higher evaporation, so more amount of water vapor is settled in the air. That's why the size of the molecules or particles are increases in the air. That's why the rays are coming from the sun. Okay, so when they are passing through this one, the size of the molecule present in the air is comparatively not equal to the any wavelength of the color. It is equal to the average wavelength of the all colors. That's why it is acts as a scattering center for all colors of the light. That's why before vanish all the colors, they reaches to our eye due to the lesser distance. That's why so sky is appears which color? White in color at the noon time. During sunrise and sunset, why the sky appears reddish in color? That is you know very clearly. For this one also. So during the sunrise and the sunset, the earth is appears to far from the which one? Sun is nothing but the distance is maximum from the earth to sun at the during the sunrise and the sunset. So that what will be happen? We know that according to the scattering of light, which color of the light having higher wavelength scattering is less, lower wavelength scattering is more. Listen very carefully. A color of light is having the higher wavelength, its scattering is less. A color of wavelength of the light is low or less, its scattering is more. That's why mostly we are observing that. Means based on this concept, we are understanding very easily this one. So during the sunrise and sunset, the distance from sun to earth is maximum. At that time, the rays will travel more distance in the atmosphere. That's why we know that according to the Planck's quantum theory, the Planck scientist says that light is travel from one place to another place in the form of quanta. It is called packet. Each packet we are called as quanta. But at the same way, one more important thing: when it during its motion or during its path, it loses certain energy. That is the E equals to h nu energy. That's why what will be happen? Generally, we know that on the surface of the earth, nearly means the crust of the sun is nearly having how much degrees Celsius of the temperature? 6,000 degrees Celsius. But as at the inner core, nearly 1 to 10 lakhs. But what I say that means at the surface of the surface of the sun is nearly having 6,000 degrees Celsius of the temperature. But that temperature of the higher wavelength of the light in the form of infrasonic. That's why when they reaches to the surface of the earth, the temperature is, what is that one? Maybe maximum, even in the summer also 50 degrees Celsius only. Is it correct or not? So means what is the temperature on the earth? Surface of the earth 6000 degrees Celsius. But on the surface of the earth, means on the surface of the moon, sorry, on the surface of the sun 6000 degrees Celsius. On the surface of the earth only maximum is 50 degrees Celsius only. But why on the surface of the earth only, why the temperature is not more than 100 degrees Celsius? Because of, according to the plants, we know that when the light is travel from one place to another place, it loses the heat, it loses some energy, that is E equals to h nu energy. Like the same way, the heat energy will be coming from the sun towards the earth or other planets. What will be happen? The heat energy will be losses its intensity of the power. Then finally it will become to the very lesser power. Due to that one, with that one only the temperature reaches to 50 degrees Celsius maximum on the surface of the earth. Anyway, listen very carefully. During the sunrise and sunset, the distance from sun to earth is maximum, and the light rays will travel more distance. During in its motion, it loses some energy. But which color will be having the higher wavelength? It will be travel more distance without much scatter due to the higher wavelength. So here, the white, the red sky is appears reddish in color. The light is coming from the earth, sun towards the earth. It will be travel more distance on the earth at that time. Okay. Due to the higher wavelength of the red color, without much scattering, before vanish, it reaches to our eye, but remaining colors will be vanish before it reaches to our eye. That's why the sky is appears which color? Reddish in color. Once again listen that during the sunrise and the sunset, the distance from sun to earth is maximum, so that the rays are coming from the sun, they appears to travel more distance in the atmosphere. That's why other colors before reach to our eye, they vanish in the air. But red color will be reaches to our eye before vanish due to the higher wavelength and less scattering of light. That is. But what is the color of the sky? The real color of the sky is black. We know that the astronauts, actually the Russia and America will be send some astronauts into the space above the atmosphere. When above the atmosphere, when they go and come and observe, what will happen? The sky is appears black in color. Because of why the sky is appears blue in color? Because of our Earth atmosphere is contain the nitrogen oxygen molecules. These oxygen molecules are comparatively equal to the blue color. That's why the light is coming from the sun. When passing through this one, it will be scattered more which light? Only the blue light than the other. That's why sky is appears blue color. But above the Earth atmosphere, what will happen? There is no air. Means there is no nitrogen or oxygen molecules, only the vacuum. That's why there is no scattering of light. Due to that one, the sky is appears which color? Black in color. And the last concept in the chapter is Raman Effect. They are asking mainly for 1 mark about this one. They are not giving the large information about this, and also no need to you for giving the more information about this one. See the Raman Effect, actually simply we are called Raman Effect. The frequency of scattered light by the liquids. The frequency of scattered light by the liquids is always more or higher than, more than the frequency of incident light. So listen very carefully. What is the Raman effect? Means the frequency of scattered light by the liquids is always more than the frequency of incident light. What is the meaning of this one? Means, okay, so for example, red color having certain wavelength in the which one? 8. So I said, for what is that one? 7,000 angstroms. Okay, this is the wavelength of the red color in the which one? Air or vacuum. But when this wavelength of the red color of the light is passing through the liquids, at that time the liquid molecules will be scattered the red color of the light or not. At that time the scattering of the red color light frequency is more. It is nothing but its frequency. Okay. 1.4 into 10 power 6 hertz, like this one. For example, we can set that. Not exact value, surely. So what I am saying means, okay, red is a lower frequency, 0.56 into 10 power 6 hertz, like this one we can set that. 1.4 is mainly for the violet. So violet has a higher frequency, red has the lower frequency. Just for understanding of you, what I am saying that means, okay, 0.56 hertz. Or maybe for understanding, I'll leave that about that one. 1 hertz we can set that. Not 1 hertz, 0.56, something like this one, into 10 power 6 hertz, that is sure. So the frequency of the, okay, means the frequency of the red light will be fall on passing through the liquids. At that time, the liquid molecules first absorb the red light fall on it with this much of frequency. Again, it will be re-emit the light by the scattering property in all directions. At that time, okay, so the liquid molecules or liquid particles will be scattered the red light with a higher frequency than this one. Okay, it is the which one? Incident light frequency. Scattered light by liquids is maybe more than this one, maybe 2 hertz or 3 hertz or like this one. That is the meaning of that. Listen very carefully. The frequency of scattered light, the frequency of scattered light by the liquids is always more or higher than the frequency of the incident light or any color. So this concept was coined by which scientist? Raman scientist. That's why it is called Raman Effect. Okay, what is the main use of the Raman Effect? Means with help of the Raman Effect, the further scientists are find the exact shape of the molecules. So Raman Effect is mainly useful to find the exact shape of the molecules. Up to Raman Effect, up to find out, up to propose the Raman Effect, up to Raman Effect, what will be happen? Okay, the scientists will be with assumptionly or with predictionly they said this is the exact, this is shape of this one like that one. But after the Raman Effect, the further scientists will be clearly find out that or exactly find out the shape of the molecules are this one exactly because of this one. Because of one type of liquid will be scattered one different frequency. Based on that one, their size they can size and shape they can easily identify. So that's why after proposing this one, the Raman scientists will be got which one? Nobel Prize, that is that. So this is the brief idea about the Raman Effect. And now the chapter concepts are completed in the chapter of human eye and colourful world. So mainly in this chapter, in the starting of the chapter, I said very clearly what is the least distance of distinctive vision, 25 centimeters per normal. Next, angle of vision 60 degrees, that is also we know that. After that one, defects in the vision, myopia cured by concave lens, hypermetropia cured by convex lens, presbyopia cured by bifocal lens, concave and convex. Concave is in uppermost, concave is in lowermost, convex. Next one, astigmatism cured by the cylindrical lens. These are the defects of vision simply. After that, we discuss about the what is the dispersion of light, how it will be occurs, what is the Newton's experiment about the dispersion of light by a prism, and further we discuss the how to find diffraction index of a prism experimentally and derivatively. And for small angled prism, what is the formula to find the minimum deviation angle or deviation angle? So this type of concepts we are discussing that. Further, we are discussing the what is the how rainbow will be formed and what are the activities for the formation of the artificial rainbow. And next we discuss that what is the scattering of light, what is the main reason for the scattering of light, and finally we discussing that application of scattering of light and the Raman effect. This is a simple theme of human eye and colorful world. In the next coming video, we start another chapter. The chapter is mostly we know that electricity. Thank you.